All right, so I believe you can definitely work out the electron configuration right here. The numbers at the top of each peak, they are like telling you the exact value of the binding energy. Okay, so I've got 3p4. Okay, so 3p4, that means in the third period, fourth column in the p block. Same column with the oxygen, but in the third period, so it's going to be sulfur. Okay, all right, sulfur. And it says add a peak to the spectrum that represents the 2s electrons of an atom with a higher atomic number. Okay, so where would you add this peak? Okay, so now for sulfur, 2s is where the 22.7 is located. Okay, so for sulfur, that's a 2s, right? So now the question is, where do you put the 2s? For a higher atomic number atom. Would it be to the left or to the right of the highlighted peak right here? Or in other words, will those two electrons in the 2s have a stronger binding energy or a weaker, smaller binding energy? Like you can think about how much energy is required to remove them. Or you can also think about like, hey, how great are they attracted? You can choose either of these two ways to think about it. There you go. That is exactly the reason. With a higher atomic number, you have more protons. And with greater protons at the nucleus, the inner electrons will be more attracted. So therefore, to put down a peak for a 2s, for the 2s electrons of an atom with a high atomic number, it must be to the left, meaning that it must have a stronger binding energy due to stronger attraction from the nucleus. Oh yeah. Oh yeah, definitely. Still. Now, when you go down in group, now that's a very good question. What happens when you go down in group? Well, the inner energy level electrons will be closely attracted, but the outer energy levels, they become more separated due to the shielding, due to the distance. And remember the Coulomb's law, how the distance being squared in the denominator. So we say, hey, as we go farther, the separation will be greater. But for the inner electrons, because you have so many more protons in the nucleus, the inner electrons will get attracted closer for that reason. Okay? For the inner energy level electrons. Now, in general, now we don't go, that it will not be in general. Because as we say, like, what do we say about the group trend for atomic radius? As we go down, it gets bigger. Okay, just like the questions that we had earlier, right? Like this one. We say, hey, which one best explains the increasing atomic radius? It's not the protons, because the size will ultimately be determined by the valence electrons or the outermost energy shells. Okay, electron shells, energy levels, the electron shells. Energy levels. You got to build a picture, okay? That's why I use a jacket as an analogy. The more jackets you put on, the more bulkier you have. Okay? But you can also think about like, hey, when you put a Mars jacket, what can you say about the inner layers? It's closer to your body too. As you go from top to the bottom, it's all about the layers. Okay? The number of protons, that's why we say, hey, is A factual statement? A is a factual statement, but A is not a statement that can explain why the atomic radius is increasing.